Hello dear students, welcome to EDTARGET. In this lecture, we are going to discuss equations of motion in kinematics. In last lectures of AP Physics series, we have already discussed distance, displacement, speed, velocity and acceleration. So, what are these equations of motion? These are equations which relate velocity, acceleration, time, displacement, etc. It means, let's say they give you three quantities and ask four. So you can use these equations to find out the fourth quantity. So there are some symbols, just like for initial velocity, we use V naught. For final velocity, we simply use V. For acceleration, we use A. And for displacement, we use X. One more thing, that displacement can be written as final minus initial, means x final minus x initial, and for time we use t. So these are the symbols, and equation of motion are the equations which will relate all these symbols. So again students, for any kind of personal mentorship you can WhatsApp me over this number. Now we will derive our first equation of motion. So first equation of motion is the relation between acceleration, velocity and time. We know that acceleration is nothing but rate of change of velocity. If you remember, formula of acceleration was delta v by t. This was the formula of acceleration. So acceleration is nothing but v final minus v initial upon time. Now we will simply cross multiply. So a can be written as a upon 1. So when you do cross multiply, a into t will be equal to 1 into vf minus vi. So at will be equal to vf minus vi. If at is equal to vf minus vi, so vf can be written as vi plus at. This is our first equation of motion. That final velocity is equal to initial velocity plus acceleration times t. So we are supposed to memorize this equation, that final velocity is equal to initial velocity plus acceleration times t. Now what about second equation of motion? So second equation of motion relates displacement, initial velocity and time. It's the relation between displacement, initial velocity, acceleration and time. So we know that average velocity can be written as displacement upon time. What is average velocity? Average velocity can be written as displacement upon time. So let imagine that you are moving on a straight line. Your initial velocity is v naught and your final velocity is v, and you cover this displacement x in time t. Again, you are moving in a straight line. Your initial velocity is v naught, your final velocity is v. The displacement from v to v naught, the displacement of this path is x, and you cover this displacement in time t. So what is average velocity? We know that it's displacement upon time. So displacement, again if you do cross multiply, so displacement can be written as average velocity into time. If you cross multiply, you will get displacement is equal to average velocity into time. So displacement can be written as x here. Average velocity can be written as initial velocity plus final velocity upon 2. Average velocity, what we can write average velocity? Average velocity here will be, average velocity will be vf plus vi by 2. So v final plus v initial by 2. So what is v final? It's v. What is v initial? It's v naught by 2 into time t. So this is our displacement. Now we have already derived this first equation, that v final is equal to v initial plus at. It means this v final, v can be written as v initial, v naught plus at. So you put here, in the place of v we can write v naught plus at. So if you put v in the place of v, what you have to do? You have to put this v naught plus at. If you put v naught plus 80, it will become 2v naught plus 80 by 2. It will become how much? 2v naught plus 80 by 2. Now what you do, you simply separate this 2. So it can be written as 2v naught by 2 plus 80 by 2. This 2 you can separately write over these 2v naught and 80. It will become 2v naught by 2 plus 80 by 2. Outside we have t. Now this 2 and 2 will get cancelled and we are left with v naught plus half 80. This 80 by 2 can be written as half 80 into t. Now simply multiply t inside, so it will become x is equal to v naught t plus half times 80 square. This is our x, v naught t plus half times 80 square. So this is our second equation, that displacement is equal to v naught times t plus half times 80 square. Now third equation of motion we have to derive. So what is third equation of motion? It's the relation between final velocity, initial velocity, displacement and acceleration. Means there is no not mention of t. You have to remember this thing, that in third equation there is no mention of t. So for that, what we will do, we will simply take our first equation. What was first equation? V is equal to v naught plus 80. Now we will square both the sides. If you square both the sides, square both sides. If you square both sides, so it will simply become v square and RHS will become v naught square plus a square t square plus 2v naught at. We will use the formula na, a plus b square is equal to a square plus b square plus 2ab. This formula we use here. Now this term, this a naught a square t square, can you simply write it like 2 by 2? Yes, we can write it 100 by 100, 1000 by 1000, because it's simply 1. 2 by 2, what is 2 by 2? It's simply 1. Now what we do, we take common. What do we take common? It's v naught square simple plus. From here you take common 2a. If you take common 2a, so what will left here? 2a. 1 by 2 is left because this 2 is outside. 1 by 2 is left. From a square, a you have taken common, so here a will be there. T square is already plus 2 is outside, so we are left with v naught t. So v square will be v naught square plus 2a, and we know that by second equation this term was x, v naught times t plus half times 80 square. This was our x. X is equal to v naught times t plus half times 80 square. So this term we can write it here. So this is our third equation. V square is equal to v naught square plus 2ax. So this was about all the three equations. Again, as a summary we can write all the three equations. First was v is equal to v naught plus at. Second was x is equal to v naught t plus half times at square. Third was v square is equal to v naught square plus 2ax. You are supposed to memorize them, so that will help you in exam to figure it out which equation we will use. Now there is a separate formula which you should remember, that how to find displacement in nth second. Remember, you can say that sir, we already know to find displacement from the second equation, so why there is a need for another formula? But remember that this equation gives you the second equation or third equation, these give you displacement in total n second, just like it will give you displacement in total t time. Just like if you drive your car for 4 hours, so it will give displacement for total 4 hours, 0 to 4 hour completely. But what if you want to figure out in fourth hour how much is your displacement? Not total 4 hour, in fourth hour what is your displacement? So for that you should use this formula. Xn is equal to v naught plus half a bracket 2t minus 1. Just like this formula will give you for total 4 hour, for example, total 4 hour, but this formula give you for fourth hour. I hope you got the difference between them. This will give for only fourth hour, means third to fourth. This will give for total, so total 4 hour. So that's the difference between them. So I think this much is clear to you. You all are supposed to go and revise all the formula, make the notes, and again, if you have any personal query, you simply WhatsApp me on my number. For any kind of study material you need, any kind of personal mentorship, you can WhatsApp me on my number. In next class, we will solve practice problems in kinematics, and we have so many questions I have taken. All of them have already been asked in EP Physics exam. So next lecture, make sure you watch and subscribe to my channel. Share with your friends who are taking EP Physics. If you have any suggestion, you can tell me in comment section. Thank you so much.